Hi everyone. Today for 2.4 we are going to discuss intercepts and look at standard form of linear equations. Go ahead and pause the video and do the recall. Okay, here are the answers for the recall. On number 1, you will notice that I start on the point on my left and I go up 1 over 2, so the slope is going to be positive 1 because I went up and over 2. The y-intercept is where it crosses the y-axis, which is 2 in this case. Over to number 2. Your slope is negative 3/5, and your intercept is b, which is 11. Number 3 is a little bit trickier because you have to distribute the 3 to the x and to the 1 to change it into slope-intercept form in order to get that intercept of 0, 4. The slope is 3. And lastly, the slope for number 4 of a horizontal line would be 0, and it crosses through the y-axis at positive 3. So 0, 3 is your y-intercept. All right, today we are discussing intercepts. So as a quick reminder, an x-intercept is where it intersects the x-axis. So here is my graph, here is my x-axis, and where they cross is at negative 2. So this example would be negative 2, 0. When we are solving algebraically for the intercepts, for the x-intercept, we're going to set y equal to 0 and solve for x. X-intercept, we are solving for x, so y equals 0. The y-intercept is the opposite of that. So my y-intercept is where it crosses the y-axis. In this case, it'd be negative 4. So since we are solving for y, this time we set the x equal to 0 and solve. Because if I look at my intercepts right here, at this point, my x value is 0. So I'm going to start by looking at the graph on example 1. It says to label the x-intercepts and the y-intercepts of the function. Now this is not a linear function, this is a different kind of function which we will talk about later this year. But at this point we can still label the intercepts. So my first x-intercept is on the left, and yes, I have two intercepts in this case. I have one on the left and one on the right. Now the one on the left has the point negative 4, 0, and then the one on the right is 2, 0. So those are my x-intercepts. My y-intercept, where it crosses the y-axis, is, I only have one of them, is 0, negative 3. Make sure you are writing your... Okay, so for example 2, we're going to go ahead and find the x-intercept and the y-intercept of each equation, and then we're going to use those intercepts to create the linear graphs. So starting with example A. Now we remember with x-intercept y equals 0. So I basically take 5x plus 2 and I replace the y with 0 equals 10. If I multiply anything by 0, it cancels that term out. So I get 5x equals 10. Divide both sides by 5. That gives me x equals 2. So my x-intercept here is 2, 0. I'm going to take 2, 0. I'm going to graph it on my graph right on the x-axis. Now I'm going to do the same thing for y, but with a y-intercept, x is 0 this time. So I take my x and I replace it with a 0, and I solve for y. So again, anything I multiply by 0 just disappears completely. So you can basically just ignore that whole section, and then I get 2y equals 10, divide both sides by 2, and y equals 5. So my y-intercept is 0, 5. Now I graph 0, 5. Now that I have 2 points on my graph, I'm able to connect them and get the linear function you see right here. And we're done. On to example B. Now I'm going to move a little faster with example B. So with the x-intercept, I'm basically going to ignore y. I'm going to plug 0 in for y, which means this whole y term is going to disappear. So all I have is 3x equals 12. So I divide both sides by 3, and I get x equals 4. My x-intercept is 4, 0. I plot 4, 0, and there I'm done. Now for my y-intercept, again, I can basically ignore all of x, because for the y-intercept, x equals 0. So I can ignore all of x, and I just focus on the negative 2y equals 12. Divide by negative 2, and I get y equals negative 6. So my y-intercept is 0, negative 6. And I'm going to go ahead and plot that there, and I'm going to connect my 2 coordinate points, and there is my line. Part A and B were both in standard form. Standard form, to find the x-intercept, you can just cover y and solve for x, and for the y-intercept, you cover x and solve for y. You plot the 2 points and you're done. However, for the other forms, we might have to do a little bit more work. We just need to remember that when it's the x-intercept, y is 0, and with the y-intercept, x is 0. So go ahead and pause the video here and give C and D a try. So as you can see with the x-intercept, it does not come out to an integer. We have a fraction 8 over 5. So we're going to do our best to graph 8 over 5. 8 over 5 is bigger than 1 because 1 would be 5 over 5. And it's smaller than 2 because that would be 10 over 5. So it's somewhere in between 1 and 2. We're going to do our best to estimate it. For the y-intercept, it's just the b value in mx plus b. So I didn't actually have to do anything. Just cover up the x and get y equals negative 8. Then connect the two to get your graph. Okay, for part D, we get some larger numbers, but we just, again, x-intercept, we're going to plug 0 in for y, and we're just going to solve for x. With the y-intercept, you plug 0 in for x, and you solve for y. So for x-intercept, we get negative 30, 0, and y-intercept, you get 0, 15. With these numbers being a little larger, we're going to have to count by things other than 1. I'm going to go ahead and count by 5s on my graph. So this would be 5. This second point would be 10. That'd be 15. That'd be 20. 25, that'd be 30, 35, that'd be 40. I'm going to do the same thing on the y-axis, so this is going to be 5, that will be 10, this will be 15, that will be 20, 25, 30, 35, and 40. I need to mark enough so that I know what I'm counting by. So if I have negative 30, comma 0, that's going to be 5, 10, 15, 20, 25, 30 right there. And then my y-intercept is going to be 15, positive 15, 5, 10, 15 right there. Connect those points, and there's my graph. Okay, so now we have gone over all three forms of linear functions. We have slope-intercept form, point-slope form, and standard form. So I'm going to take a minute and discuss each form and what they give. The characteristics that are easiest to find in slope-intercept form are exactly as it says, slope and the y-intercept. The slope is m, what is multiplied by x, and your y-intercept is the b, which is by itself. With point slope, you're given exactly as it says, point and slope. Remember with the point, it's opposite x, opposite y, and then my slope is my m again. Now our new form, with standard form, we are actually given the intercepts. So if you cover up the x, your intercept for y would be just dividing both sides by b, and you get c over b. To find the x-intercept, you would cover up your y, and you just divide by a to get c over a. So for standard form, you just cover up x, cover up y, solve, and plot those 2 points. So now we're going to go over the 6 different situations we can have when we are graphing lines, and the steps to graphing, and how to do it most efficiently. Go ahead and pause the video and write down the steps, and then we'll go over an example of each. With slope and y-intercept, we're going to do a BM chart to find our B, which is our intercept, and our M, which is our slope. So starting with B is one that's by itself. So in this case, it is negative 1, which means I'm going to go to my y-intercept, and I'm going to go to negative 1, and I'm going to plot a point. Then I'm going to move on to my slope. My slope in this example is negative 2/3. Since it's negative, it means from my B, I'm going to go down 2 and over 3 and plot another point. Then all that's left to do is to create the line that goes through those 2 points. And that's graphing in slope-intercept form. Next up, graphing from standard form. So I'm going to start by finding my y-intercept, which means I'm going to ignore my x, and I'm just going to solve for y. So when I do that, I divide both sides by negative 5, and I get y equals negative 4. Then I'm going to do the same thing for my x-intercept. So I'm going to ignore y this time. 4x equals 20, divide both sides by 4, and x equals 5. So I go to 5, 0, and draw a point. And just as I did before, I'm going to connect my 2 points, always making sure that we extend through the entire graph. All right, given a slope and a point, all I have to do is start with my point 0, 4 and graph 0, 4. And then I'm going to move with my slope m. So my m is positive 2, so that means I'm going to go up 2 and over 1 because I can write 2 as 2 over 1. So I'm going to go up 2 and over 1, but I'm off my graph if I do that. So instead of going up 2, I can also go down 2 and left 1. If I reverse both of these, then it stays the same sign. So going down 2 and left 1 creates the same slope. And there's my line. All right, last but not least, if I'm given 2 points and all they want me to do is graph, I do not need to write an equation. I can just graph the first point, which would be 1, 4. So 1, 4, and then graph the second point, which is negative 2, 5. And then all I have to do is draw the line through those 2 points. All right, those are the 4 different situations that they can give you. The last 2 are some unique situations. It's when I have a horizontal line or a vertical line. So if I'm given a linear function that only has one variable, these are the 2 situations. I can either be given a form that's y equals a number or x equals a number. If it's y equals a number, you just draw a horizontal line through that number. And if it's x equals a number, you draw a vertical line through that number. Here's why. If I go to y equals 3, that would be right here. Y equals 3. What this is saying is no matter what x is, y is always going to be 3. So as I go through all the different situations of x, it doesn't matter. Y still stays 3 the entire time. Same thing is true, but kind of with reverse statement with x. So I go to x equals negative 1, and no matter what y is, this time x stays negative 1. So the entire time throughout my graph, I don't care what y is, x is always going to be negative 1. And those are all the different situations you can be given on graphing linear functions. Thanks, guys. Bye.